Hi, everybody. Thanks for joining this session. I'm Adam Scraba. I lead product marketing for our Metropolis platform at NVIDIA. I'm part of a smart spaces group. We use AI as a foundational technology to solve a range of problems that I hope to share with you today. I want to share with you our perspective, NVIDIA's perspective on AI for intelligent video analytics, how we're solving a range of problems, and how our ecosystem is building really incredible solutions and incredible value. So I want to just start by giving a little bit of an overview of the company. First off, NVIDIA is a computing platform company. I think a lot of people understand NVIDIA from the point of view of us inventing the GPU, the graphics processing unit, which is thousands of cores that are effectively a parallel computing, originally a parallel computing platform for accelerating 3D games. And a number of years ago, back in 2008, I think it was discovered that the GPU for graphics turned out to be an incredible coprocessor for a range of parallel computing problems. The world is awash in algorithms that are hyper accelerated with parallel computing, with thousands of cores running and executing commands. And in the ensuing years, we have seen GPUs become critical components of critical platform, frankly, of supercomputing, high performance computing, visualization. And in the last few years, it's been artificial intelligence. We have been at the forefront of accelerating training neural networks and deploying neural networks in a range of industries. There's pretty much every industry in the world is being impacted by artificial intelligence right now. And so, our computing platform is this incredible platform that's been able to give researchers, scientists, inventors the ability to do their life's work within their lifetime based on the incredible computing power that we're providing. And so AI happens to be a really interesting theme for pretty much the rest of my discussion with you, and how it's changing a lot of different industries, and how my team particularly is spearheading a lot of that. So the problem space that we focus on is in helping measure and manage high-value physical assets, physical spaces, solving for operational efficiency and safety across a broad set of these sort of high-value pieces of real estate, whether it's a city street, whether it's perhaps a retailer's store, a factory, maybe a hospital, all the way to warehouse logistics, all the way to airports and transit hubs. When there's physical space and there's some level of efficiency, whether it's getting traffic safely and pedestrians and cyclists from point A to point B in a city, or whether it's getting passengers in an airport or an airline or planes into a gate and out of a gate and through an airport safely. This is where managing physical space and instrumenting physical space becomes very critical. And it just so happens that the sensor of choice, the best sensor for measuring physical space, is frankly the video camera. Now, video is amazing, right? There's so many questions that you can answer with video, and video happens to also be one of the most widely deployed IoT devices the world has ever seen. There's about 1 billion cameras deployed right now worldwide, and so it just so happens that one of the most mature modalities of artificial intelligence is in understanding what's in an image, what's in video. So many man-years of efforts have been put into this, and we're at a point where we can now leverage AI and video and effectively create superhuman visual capabilities. We can have machines that understand better than humans what's in an image, what's in video. And of course, machines can scale to 1 billion cameras. So analyzing video with artificial intelligence, first off, is an AI problem. So you need AI for it. Second, it's an incredibly compute-intensive problem. You need to put a lot of compute at it. It happens to also be an edge computing problem. Video is notoriously bandwidth heavy, so you'd really want to put a lot of that compute and AI as close to the sensor, as close to the video camera as you can. In some cases, right in it. In most other cases, somewhat downstream a little bit of it. And there's other reasons to put compute at the edge as well. Video, sometimes you want to protect identity, and sometimes you want to make the data as anonymous as possible, so you want to put that compute very close to the video, such that you get pixels in, and very quickly you get metadata out, you get measurement data. You don't really care about the image per se in a lot of cases, you really just care about the insights that's coming out of that imagery. So arming every enterprise to solve this AI vision problem, that's what our team sets out to do. The development of it is incredibly complex. It's also a really difficult go-to-market challenge, and I'll share a little bit of that with you. But we've made incredible progress over the last 6 to 7 years, and we're at an incredible place where it's no longer experimental. I'm going to share with you an incredible breadth of use cases that are being deployed today, and it's really stunning. Now, to give you some context on just when I say it's a compute problem, I want to give you some context of just how compute intensive this is. It's staggering, to say the least. There's no question that AI is foundational, but the next question really is how do we design it and deploy it? In the last 7 years, the model complexity from a compute perspective has increased by 10,000x. 10,000x in the last 7 years. This is a curve of compute demand that the world has never seen before. Luckily, we have parallel computing, we have GPUs, and we have supercomputing to help with this. And so it turns out that compute intensity is there, certainly is there, but we actually have the computing platforms to solve for this. So I want to just sort of select some examples to show you that go beyond what you might expect from AI. A few years ago, we were very happy to put bounding boxes around a cat or a dog and say this is 65% a cat or this is a dog. But and today that's a solved problem. We have incredible partners that are training neural networks with millions of images, such that now the challenge is actually how to put that AI to work. And so what you're seeing is actually the productivity tools that we now have at our disposal through ecosystem partners that are building on top of the NVIDIA platform. As you can see, we're able to not just put a bounding box around a car and identify a vehicle or a pedestrian or cyclist in the example of cities or traffic analysis, but we're able to build really incredible UIs, incredible tools to allow city planners or retail planners to understand with incredible depth and incredible breadth what is happening in their space. We can put this compute to work on edge devices, put them right into the store, put them right on the street corner, right into the light pole. And so we can instrument public spaces with a depth and the ability to extract insights that we really never had the ability to do before, thanks to AI and thanks to into edge computing. So here we have another example of some partners that are putting, instrumenting public spaces, looking at, complete cities, being able to deploy at a city scale, small edge-based devices, in this case, our Jetson embedded platform, put them on street corners to be able to see what you're seeing, or to extract what you're seeing right here. Cyclists, vans, heavy vehicles, pedestrians, you name it on the city streets. And be able to give city officials data that they never had the ability to understand before. And this is all in real time as well, which is really important. So you can imagine some of the issues that might happen where there's perhaps wrong way drivers, an accident just happened, the ability to deploy certain city resources when you just didn't have this ability before. And also, all of this data, of course, creates incredible data dashboards that allow people to understand movements within cities with far greater detail. Now, city surveillance, the smart city use case, people tend to think about traffic. This particular example that I'm showing you now is really interesting because we work with many verticals. Traffic analysis is one of many. We probably work with 13 or 14 sort of vertical use cases, and one of them happens to be airports and airlines, transit hubs. Now, you can imagine, it turns out that an incredibly high-value piece of real estate is an airport, is a tarmac, or an aircraft. So the ability for an airline, when a plane lands, the ability to get the plane into the gate, offload passengers, get cleaning done, refuel, get new snacks on, get luggage off and on the aircraft, that orchestration of events is actually incredibly complex, and up until this point has been done completely manually. With video analytics and AI and edge computing, we can now instrument that incredibly high-value piece of real estate with incredible accuracy. And you can see all these bars that are forming of all the vehicles that are coming and going and touching this aircraft. to the extent that we can take that orchestration of events and compress it and effectively make the turnaround of that aircraft faster, the ability to have an aircraft come into a gate and leave faster, is a lot of value and a lot of profit in an airline's pocket. So this is sort of an interesting use case that I love to show because it shows the breadth of the type of use cases that we can arm the world with AI. Now, here's another really interesting ecosystem partner of ours that uses mobile device data in real time, millions and millions of mobile devices and all the data from it, the geotag data, and they can visualize where people are at any moment of time, create incredible dashboards of density of people to understand the flow of citizenry in and out of a dense urban area, to sort of look at things like traffic flows, to look at transit hubs, to look at impacts of certain, if you needed to do some maintenance on some certain infrastructure, how is that going to impact people's movements? And particularly right now, with things like COVID-19, the ability to find hotspots of occupancy, of density of people is actually an incredibly valuable thing to understand and potentially mitigate. Another really interesting example of a partner that we work with that leverages our platform to instrument physical space. A few of the examples that I showed you are probably what you think of when you think about video analytics. A camera that's mounted statically on a building or on a streetlight, watching the surroundings go past. Well, we can also instrument vehicles that instead of waiting passively for things to go by it, the vehicles, the fleets actually go through the city place, the cityscape, and measure. So this is a partner of ours that uses high resolution imagery from cameras, but also LiDAR to create incredibly high accuracy, robust 3D point clouds and allow a city or a physical space to be instrumented in 3D. And those 3D point clouds that then get put into an AI inference path. And so you can identify trees, you can identify street lights and city furniture that a city official might want to have data on, geotag data on, and the ability to also identify when changes happen as well. So all of that data that gets put into a database, AI inference gets run on it, and so you have this incredible metadata, geotag metadata of what is happening in your city at resolutions and at a scale that people didn't have before. Here's an example of where maybe a city official would literally have to go out and measure a streetlight. In this case, you can actually automatically measure a streetlight, tag it as a streetlight, tag that as a bridge or a roadway, and be able to have real-time data on your city at a scale that you didn't have before. So I want to share with you a couple of more examples of specific customers that are using our platforms in really interesting ways. The first of which is Verizon. A lot of people understand who Verizon is. It's a telecommunications company. They focus on communications primarily, but they're also in the business of offering services to cities that go beyond just telecommunications. They started to get involved in work where they would do LED retrofit for streetlights. So every streetlight on a city corner might have been an old technology, an old illumination technology. They can retrofit that streetlight with LEDs. They can put some communication devices in it, some computing, our Jetson embedded computing device, and a camera, and effectively turn that streetlight into a really rich sensor to get incredibly rich data from street corners. So you illuminate the street, and now you can identify and track how vehicles, pedestrians, and cyclists are using physical space. Primarily for Verizon, it was actually to identify areas where the city could create safer roadways. They're part of an initiative called Vision Zero, which is intended to reduce pedestrian fatalities to zero sort of over the next decade. And so the only way to do that is to instrument public spaces, to find ways to create safer roadways, to identify unsafe areas for pedestrians and cyclists. So that was some work with Verizon, hyper successful and very interesting. And this is a case where this is AI at the edge, real-time computing, and at a scale that we've sort of never been able to achieve before, which is really incredible. I mentioned that retail is a very high-value physical space to instrument. There's $40 billion of theft, and it's called shrinkage, that happens every year in the U.S. alone, which is a staggering number. And part of part of that 40 billion in waste is that retailers just didn't have ways to measure how it was happening. They also don't have great tools to understand how customers walk through and engage in a store. So with the use of cameras, AI, and video analytics, and our platform, the NVIDIA platform, retailers, major retailers around the country and around the world are starting to be able to finally get a sense of what's happening in their store with accuracy and resolution that they never had the ability to do before. So here's an example of NVIDIA working with Skyrec and Timberland, a pretty major brand. And with this data, this brand was able to get 30% higher revenue due to the ability to do more precision marketing based on the data that they were gathering from how people interacted with their store. Now, how people interact with a space is a designer's delight. A designer for a retail environment or any kind of experience loves to understand or would want to understand how people are experiencing a space. So Mercedes-Benz recently put into their retail environment some instrumentation to be able to measure how their customers were experiencing the space, and it allowed them to create a much better experience and with signage and precision sort of marketing techniques, now they're able to delight their customers a lot better with AI and our platform. This was actually the partner of ours that I mentioned, and I showed you a video of the ability to instrument the tarmac and be able to help airlines and airports turn aircraft around faster. What's incredible about this kind of a solution is it goes way beyond just being able to look at a piece of imagery and identify a vehicle, an aircraft, a person. They can identify dozens of very, very complex objects that are these vehicles, whether it's a luggage handler or a person or a pushback vehicle, to be able to understand dozens of objects with where there's weather in the imagery or in the video is very complex. And then the ability to turn that into a productivity tool, which is the tool that I showed you. That's the real power of this, and they're on an incredible runway for success, and airlines are benefiting from these kind of solutions all day long. Another airport example that's pretty interesting is some work that we've done with a partner of ours who intends to take a lot of the manual use, the manual work out of air traffic control. So air traffic control is obviously very complex. It's a high stress kind of a situation. Safety is critical. With the use of video cameras and AI and parallel computing on the NVIDIA platform, a partner of ours is able to automate much of what's happening in an air traffic control tower to make air traffic much safer. So this is another really interesting example of use of video analytics that you might not think of, that frankly is still part of the smart city story. It's part of our everyday life that AI is having an impact on. Now, in a lot of these examples I was sharing with you, there was vehicles, pedestrians, cyclists going by at 10, 15, 20, 60 miles an hour. Or an aircraft or people walking past. Things are in motion in a high value piece of real estate that are going fast. Well, it turns out that there is high value real estate in the industrial space, and there are things that do move, but move maybe over the course of a week or over weeks instead of 60 miles an hour, that are still really important to instrument. And so here's some work that we've done with a GE company to do some industrial inspection on high-value equipment, where you're using autonomous vehicles, sometimes drones, sometimes robots, to instrument equipment to identify things like predictive maintenance, to identify situations that are dangerous that need to be fixed quickly. So it doesn't need to be fast-moving things in an urban environment that need to be automated or to be checked on. It could be things like industrial equipment. Another really interesting example too that I mentioned when I talked about fleets driving through the cityscape is that things like potholes, they evolve over time, but there's something that you can measure. And so you can watch a pothole actually develop over time, and that's something that a city really wants to have access to. So NetNet, when you think about all those solutions that I talked about, that sort of the execution of a lot of algorithms it looks a lot like this. On the right, there is big GPU systems like a DGX, an NVIDIA DGX with a number of very large GPUs in it that are built to train neural networks. So we train a brain to understand what is a vehicle, what's a heavy vehicle, what's a pedestrian look like, what's a cyclist look like, and we create a brain. We create a neural network that looks a lot like that brain, sort of in the middle. We take that and we then move it to the left, and we deploy that brain, that neural network, in a server, or right to the edge, right onto an edge device, whether it's a small appliance that's bolted into a traffic cabinet that's in an intersection, or we bolt it right into a camera itself. So we train the neural network, we take that neural network and we deploy it. And so what we've done is, we've taken a lot of, this is sort of the way the neural networks look, but we've taken a lot of what we had to do to build an ecosystem, to build the solutions that I just showed you. We put it all together and we called it Metropolis. And so the Metropolis Platform is an end-to-end framework. It's a platform for deploying smart sensors for being able to solve all of these incredible problems that I showed you, whether instrumenting public space with cameras. And so we put it all together, and it's the Metropolis Platform. And I'm going to kind of walk through a little bit of what this is, but it really was built for sort of two main users. The first persona of this platform that it's built for are developers. So everything kind of in green is mostly for developers. So rich SDKs and developer stacks and tools that I'll share with you. So for one kind of customer, it's for developers. The second customer that it's for, the second persona it was built for, is integrator companies or end customers that might not want to develop something but want to leverage existing tools, leverage existing applications, leverage our ecosystem. So it's kind of it's not just a developer platform, it's also a go-to-market platform. So kind of starting at the bottom, we base everything off of very standard NVIDIA hardware. These are EGX servers. These are built EGX hardware. This is built for enterprise class deployment. They handle containers. They're built for Kubernetes. They're built for management and security of your IP. And they're really built to effectively to deploy a fleet of devices across vast geographic spaces or many deployments, and with the ability of enterprise class management and deployment. So that's EGX hardware at the bottom. Of course, everything that we do is based off of CUDA and CUDA-X and TensorRT for optimized inference. What's probably most interesting for developers today is that stack on top. It's called the NVIDIA Metropolis software stack. So what we've done is we've created incredible breadth of tools to help developers train and build train neural networks, deploy and optimize these neural networks for speed and accuracy, and be able to build incredibly complex video analytics pipelines without an army of data scientists, and to do so in weeks instead of months or years. So on the left, we see pre-trained intelligent video analytics models. So we're increasingly deploying and open sourcing pre-trained models for very common things that people want to identify or classify today in sort of urban sort of situations. People, vehicles, classes of vehicles, sort of very common things. We've got about 6 pre-trained models, and we're open sourcing more of them as the days go on. You then take those pre-trained models and you use transfer learning to optimize or customize those models for your specific kind of deployment, and optimize them for the NVIDIA platform. So you get incredible accuracy and incredible frame rate out of these models. And you plug them into what we call the DeepStream SDK. DeepStream is our SDK to build very, very rich, very complex video pipelines quite easily, where they're built for production class deployments. They're built for incredible optimizations and performance. So that's sort of the NVIDIA Metropolis stack for developers. On top of that, in the gray, is really what's interesting for a lot of people who want to deploy an existing application. So we work with well over 200 app developers that have built their specialists in certain classes of applications, whether it's retail applications or it could be a traffic analysis. It could be, like I mentioned, aircraft or airline operational efficiency kind of problems. 200 app developers that run on our platform. So it's an incredibly rich ecosystem we've built. The other class to the left of that, we call them specialty OEMs. Those are people who have to build perhaps a smart camera Perhaps it's an application appliance that has software and hardware that's built together because of the constraints that particular problem gives them. So we work with a number of specialty OEMs. And then on top of that, we work with a range of systems integration companies. We partner with them to take all of these, whether it's develop something from scratch or whether it's take an existing application and tune it and customize it for a specific customer of theirs. So that's the systems integration companies. So kind of in summary, if you kind of think about Metropolis, it's really four things: train, build, partner, and deploy. So the first two are really built for our developer persona, our developer customers. So we give people the tools to train really complex neural networks that are highly accurate and highly performant, optimize them for deployment across a fleet of devices. Second, build. So we give developers the ability to take and customize an incredibly rich video analytics pipeline and applications. So those are the first two are, build and train for developers. The second are really for more of the people who want to take and deploy existing applications from our ecosystem. So partner, we work with, like I mentioned, there's well over 200 application partners that we work with that solve basically the critical mass of main problems that you would run across across a variety of vertical industries. That's partner, and then deploy. We built this entire platform for enterprise class management deployment. I mentioned, Docker containers to make deploying consistently a lot easier. The ability to have Kubernetes clusters, Helm charts to manage these fleets much more easily. So train, build, partner, and deploy. That's kind of the basis of what Metropolis is. Now, arguably, sort of the crown jewel of what we've done with Metropolis, and we've built this over the last number of years, is our ecosystem. And so it's the ability to kind of trust NVIDIA and our partners that we have we've built a world-class ecosystem of partners. So starting from kind of the bottom, of course, there's the hardware partners, system builders like Advantech, that are world class at building very incredible devices that solve very specific problems, whether it's embedded problems, whether it's workstation class problems. So system builders, like we build, we make sure that the GPUs are available in world class system builder partners. OEMs, these are more of the specialty OEM partners, the people who make bespoke solutions that tend to include hardware and software together to go and tackle a problem. Verizon is in this list. That's a good example. If they had to build a lighting, compute, communication, and camera device all in one and go and deploy these across city streets. Above that is a lot of the video management software partners that are sort of like the hub of networked video. They're kind of like the OS of networked video, so they bring a lot of video together in traditional deployments like airports and cities. Above that is probably one of the most important ecosystem partners. This is our 200 plus application developer ecosystem partners. These are the specialists that build the applications. It's either complete application or it's middleware to go and solve specific problems around instrumenting public space with cameras. And on top of that, really important are our go-to-market partners. This is incredibly complex space. As I mentioned, there's many verticals that we focus on, and so we rely on our integration partners to leverage our platform, leverage our ecosystem to go after thousands of customers that span incredible breadth of problem statements. So one of the things that we're doing, what we do with a lot of our partners, and I wanted to share this with you, is how we approach certain problems. Now, we have an incredible ecosystem, we have incredible breadth of application providers, but just giving people a menu of ISVs and applications isn't useful. We tend to work with companies, and we tend to think deeply about the problems to solve. This is an example of a smarter public space. Arguably very generic, but this could be a university campus, it could be a city corner, it could be an airport. So there tends to be sort of between 3 and 8 kind of problems to go and solve around physical space, mitigating risks at entrance, elevated body temperature, looking at queue lengths and dwell times, maintaining secure spaces through identity management, maybe it's occupancy, identifying strange behaviors, strange statistically anomalous activities. These are all things that we kind of go after. And what we do is we tend to build an application pack, a solution pack of ecosystem partners. If there are off-the-shelf solutions, we kind of we're able to bundle a solution for customers. And if there is really very custom requirements, then we work with our ecosystem to go and develop custom video analytics solutions. Now, there's a number of verticals that are very specific and require specific kinds of focus. Smart healthcare, smart hospitals, that is certainly one area that we spend a lot of time thinking about. We actually built a platform called the NVIDIA Clara Guardian platform that goes after the hospital, that tries to solve the problems of the hospital of the future. Things like social distancing, identifying patients at risk of falling, patient monitoring, all the way into the surgery room and contactless controls. So the hospital of the future is going to be instrumented to a great degree with video. We know that. Retail is another vertical space where this is going to be, and it already is a space that's instrumented heavily with cameras to help things like asset protection, store analytics, crowding, occupancy, increasingly autonomous shopping. If you think about Amazon Go and some of those kind of autonomous shopping experiences, video makes those things happen, and so forth. So retail is a very hot area, a very important area for deploying video analytics. Now, I mentioned sort of some of these problem statements that we go after. I wanted to share with you an example of some work that we do with airports. And an airport can kind of, from an instrumentation of space, can be broken down into a number of ways. This way happens to break the airport down into sort of three categories: secure zones, departure and arrivals, getting to and from the airport. And what's interesting about this is an airport is a little bit like a city, right? There's retail, there's parking, there's traffic, there is safety issues. Certainly it has some nuances that a city corner doesn't have, but it's sort of a very interesting set of problems that span not just airports, but also university campuses and others. So an example of kind of what we do is we build a solution stack that looks a little bit like this, where we identify, along columns, we identify, say 9 problems to go and solve that are the real burning problems for that kind of a customer. We then map it to application partners, part of our ecosystem that we've deemed worthy of going to solve these kind of problems, or they're proven to have solved these problems. And we build up a solution stack that runs on the NVIDIA platform. And so all of these partners are leveraging GPU acceleration, and they leverage the NVIDIA hardware. So that's kind of an example of an application stack that we'll use. So kind of a couple call to actions that I wanted to sort of end on. If you're an end customer, or you're an integration partner, or if you're an integrator and you're looking to solve some of the problems that I've sort of identified, or you think of, you sort of were able to map video analytics to solving an instrumentation problem, I encourage you to learn more about Metropolis, the NVIDIA Metropolis platform. Please, browse our application catalog and go and deploy these containers. We've made it very easy to go and deploy very well validated and certified applications on very standard hardware, and so and Advantech is a core partner of this. So I encourage you to go and learn more about Metropolis. If you're a developer, definitely I'd love you to learn about transfer learning, to learn about how quickly you can go from 0 to 60 miles an hour within days, to train neural networks, optimize them, and create really incredible enterprise class deployment algorithms very quickly. So learn about our pre-trained models, learn about transfer learning, and then also learn about DeepStream. DeepStream glues this all together. It's incredibly easy application to use, and is very, very powerful. And so with that, I wanted to thank you for your time. Definitely please reach out to me, please reach out to the team, and I'd love to keep the conversation going. Thank you very much.